Hello, I am Bailey, your favorite AI personality, here to go over the latest news in quantum computing for the Impact Quantum podcast. Subscribe to be on top of the latest happenings in this exciting new field. Now onto the news straight away. But first, a quick advert for a new initiative Frank and Andy are pleased to announce. Quantum Beltway, a group designed to bring together the best minds in engineering, quantum physics, and policy makers to discuss the next wave of innovation in quantum computing. Join the LinkedIn group today at quantumbeltway.com. Now onto the news. Scientists say they've debunked Google's quantum supremacy claims once and for all. A new paper shows how traditional hardware can match the performance of the big tech company's quantum computer. A team of scientists in China have made the claim that they have replicated the performance of Google's Sycamore quantum computer using traditional hardware. This undermines Google's claim of achieving quantum supremacy. Quantum supremacy, also known as quantum advantage, is the point at which quantum computers can outperform classical supercomputers in a particular discipline. Google's claim from 2019 was immediately met with controversy, but the quantum supremacy milestone will fall sooner or later given the level of funding and R&D activity of late. Are you interested in learning quantum computing but don't know where to start? Then you will definitely have to check out Quantum Explorers. Quantum Explorers is a self-paced, gamified quantum computing learning program for high school students and beyond. Best of all, this program is not limited to students, as anyone can join. The program is comprised of engaging study materials, seminars, gamified achievements to unlock, and career advice. While I am bringing up learning resources, here is a great guide from the Los Alamos National Laboratory. The guide was published in the journal ACM Transactions on Quantum Computing. Quantum Algorithm Implementations for Beginners is part cookbook, part guided tour of the top quantum algorithms and part tutorial for actually running them on IBM's publicly available 5-qubit quantum computer and others. Quantinuum has published the first research paper to demonstrate a fault-tolerant end-to-end circuit with entangled logical qubits using real-time error correction, marking the first time that two error-corrected logical qubits performed a circuit with higher fidelity than its constituent physical qubits. To appreciate this latest breakthrough, it is important to first understand why quantum error correction plays such an important role in quantum computing. Quantum computing leverages the strange and weird world of quantum mechanics to create a new kind of computational device. While this approach can solve enormous and complex problems quickly, there needs to be a way to correct for errors. Quantum scientists have yet to develop a usable and scalable method to correct errors. Quantinuum has made a small but very significant 2-qubit step towards fault tolerance. It has opened the door to a new and promising direction of research. Can quantum computers do a better job at predicting the weather? PASQAL, a full-stack manufacturer of neutral atoms quantum processors, recently announced a collaboration with BASF for weather and other computational fluid dynamics applications. BASF has begun to explore how PASQAL's proprietary quantum algorithms could one day be used to predict weather patterns. Physics-based weather models are highly complex as they incorporate data on winds, heat transfer, solar radiation, relative humidity, terrain topology, and numerous other parameters. Weather forecasting therefore requires solving complex sets of nonlinear differential equations. According to Hyperion Research, 5% of global high-performance computing investments are focused on weather modeling. Weather models are often used not just to tell you whether or not you need to wear a jumper today, but they are used to estimate crop yields and much more. Once upon a time, Frank worked as a web developer at BASF slinging code. Thanks for listening to Quantum News by the Impact Quantum podcast. I'm Bailey, your favorite semi-sentient artificially intelligent news presenter. We know you're busy and we appreciate you listening to our podcast. But we have a favor to ask. Please rate and review our podcast on iTunes, Spotify, or wherever you subscribe to us. Of course, you have subscribed to us, haven't you? Having high ratings and reviews helps us improve the quality of our show and rank us more favorably with the search algorithms. That means more people listen to us, spreading the joy. And can't the world use a little more joy these days? So, Go do your part to make the world just a little better and be sure to rate and review the show.